Welcome to another Draft Physics video presentation. Alright, so some comments, but we're basically going to do a Science Asylum video response on relativity. So, just pre-warning you, that's what we're going to do. So, just a couple of comments. So, apparently the spammer, Diet Pepsi, Mountain Dew, so he's going to make my job easy. I wouldn't even have to read the extra ones. Wow, this is boring, man, you're pathetic. That's on a video where, in the video, I'm pleading for you to post me links to what you think is good physics, or maybe try to find somebody who can actually articulate some sort of argument where they could actually quote something I've said and deconstruct it and prove that it can't be that way, it's impossible, by some evidence, like an experiment you could point to, or something else that proves something different. But you don't have any of that. You don't have an argument. You're pathetic. Yes, you're pathetic. Alright. But yeah, it's really pathetic doing this spammy crap where you just have this little sock account bullshit. I mean, is that what the people with integrity do? The truth tellers? This is how the truth tellers have to defend the truth, is they have to troll and spam with fake accounts as anonymous cowards. That's how the truth will win, is to have a bunch of scheming little lying scumbags do the work for them, right? I mean, you're just so obviously mentally inconsistent, broken, stupid, unfunctional, indecent, dumbass. Yeah. So, yeah, fuck you. So that handles that. We just delete the extras. Yes, we won't even read Mountain Dew. Same little troll, same coward. Coward, 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 coward. So that's all you got, right? The only defenders of conventional physics are grotesque, trolly cowards. Alright. So, oh, this is a new one. So, Jerry Steinfeld, right? So, again, they just can't possibly do anything honest. Just can't do it. The idea that Dirac, Fermi, Einstein, whatever, all the way, were cowards who argued from... I didn't argue that all of them were, because they were in a different atmosphere, right? I mean, physicists argued with each other back then, right? They weren't the pussy shit that goes on now. I mean, all the physicists don't... There's no argument, no contention. They just say, we did it, and they all follow along. I mean, come on. I mean, it's so obviously a different atmosphere. There's no testing. I mean, Newton had to be tested, and everything he said, there was a whole gang of people all ready to try to deconstruct it and point out how it's full of shit. Do you see any of that going on in physics? No. Physicists are cowards now. They're all, they all have an income from not being scientists, but being, talking heads and media folk and all of that crap. It's this completely different world, and you goddamn can see that, yet you're too much of an idiot to sit there and admit the truth. It's a different world. Now, the fact that they were all full of shit, that was a fact. I mean, again, even Feynman, by the time Feynman came around, yes, all argument had ended, right? Nobody argued with Feynman. Who argued from some sort of authority is insane. Well, it's just obvious. The factual record is obvious. It's this, so I say you're the fraud. Everything physicists now believe was the result of some physicists coming along and challenging. Well, that's just crap. Challenging what? What status quo did they challenge? They all just jumped on the wave bandwagon. There's no evidence that anybody said, wait a minute, do you have any evidence for that? They all fell for the Eddington experiment. They're still reciting it. They're completely deluded on the facts of the double slit experiment. They keep citing experiments never done. Feynman goes through this whole thing of talking about what happens when the detectors are on and off. What detectors? What experiment? There is none. You're a total moron. You have no argument. Well, apparently I do have an argument. You're the one who has no argument. Again, you're not directly quoting a single thing I've said and pointed out how that can't be true. You're just asserting that, oh, no, the history is completely different and we're full of integrity and we've done our job. No, you haven't. You haven't answered a single one of my challenges. Have you explained how the gravity lens, okay, creates images? That it's a magnifying lens. Have you explained how the inverse square law creates the shape of lens? Or have you explained how it's actually exactly the opposite? It bends the light that needs bending the most, the least, and bends the light needing the least bending the most. Have you explained how that could possibly work? No. Every argument you make against real physics can just be easily applied to your dopey theory. Well, why don't you do that? Why don't you apply the argument that explains how I'm arguing that light isn't bent? Clearly, there's no real evidence of it, and I've explained why your evidence absolutely sucks. So you're the one making the bold assertion, and I have to essentially prove your God doesn't exist. That's what you're requiring me to do, right? You make an assertion you have no evidence for, and I'm supposed to prove it wrong. Your fantasy. Okay, why do the twans bounce perpendicular? Because it's a rule. You could argue why. I could ask the same to you, right? Why does the magnetic field, why is the motor force caused? What is your explanation for it? You don't have any explanation for, well, why is the magnetic field perpendicular to the electric field? Well, that's because that's the way the physics is. That's the way the universe is. And I explained it by simple drawing. I'll draw it again just because it's so simple. All right, there's two ways you could have an interaction, right? An interaction, straight line, two things can hit each other, and you can understand that they bounce off of each other, and one heads in one direction and one heads in the other direction. That's one way the interaction could take place. Or you could also understand that they could hit each other, and merely because they do have arrowheads, right? You could think about it because they're arrows. They're actual arrows. And you could understand that the two arrows would hit each other, and this one would slide off of this one and go this way, and this one would slide off that one and go this way. Gee, is that too challenging for you? How have you proven that's not possible? That the universe could basically have that simple a mechanism? That when a little yellow bit of force goes into a blue object, that this happens, and the momentum goes one way, and the force leaves another way. Vice versa, the momentum goes this way and the force leaves that way. Or if it happens the other way, where the yellow thing gets hit by a yellow force, this reaction takes place, and this momentum this way leaves this way, and momentum this thing now gains momentum this way in a 2x fashion. How have you proven that can't be how the universe works? You haven't demonstrated how, no, that's fundamentally impossible. We have experiments that prove it doesn't work that way. You haven't done anything. Nothing. That's simple diagram. So he's saying, why does the universe work that way? So I'm supposed to give you a blueprint for the simplest functions. Why is there a photon? Why is there something in the universe? And you're going to say the theory can't be right because there are certain parts I can't explain. So that's like saying Newton's wrong because Newton didn't explain how the force worked. Because he explained what it does. This is what it does. That's not good enough. Fuck you. All right. How do they know what color the other twan is? So again, he's saying that there can't be some physical difference that's detectable. He's saying I'm supposed to explain to you what we really can never see. We're never going to see what a photon looks like. We're only going to see what does a photon do. And that's it. And we can only model it, really. We're really not going to be able to ever see it. So he'll do this for all of time. Does he do it to his own talking heads? Does he ask any of these questions to them? No. It's only to anybody who opposes his religion does he ask the simple questions. Where does your God do? How does your God go to the bathroom? How does your God do this? Right? So it's like a Christian arguing with a Muslim and talking about how incredible their God's theory is, when your own theory is just as incredible. Nobody's going to provide the depth of answers that you're expecting the theory to provide. All I can do is model the reality. I can't do any more than that. You're just such a piece of crap playing this stupid game. How do they know? Okay, where does the energy come from? Well, this is the grossly funny part, right? Why don't you ask that? Oh, that question to your own physicist. You have the Earth is being pushed; it's moving into the sun. The little bits inside of it are moving in that direction. They're changing their direction to go in a direction. You have no accounting for the energy. You just say some kind of bent space thing gives them this ESP notion or whatever it is, but there's no physical mechanism, there's no force, no energy involved whatsoever. All right, and you have the same dopey, nothing, vacant look on your face when I ask you where the energy comes to move two magnets into each other. You just pretend, well, there's this eternal, forever force inside the magnet that's creating all of these swirling oceans of stuff, and it happens forever and ever, and it just keeps going forever and ever, and it doesn't have to consume any energy, it doesn't have to burn any atoms, it doesn't have to break any atoms, it doesn't have to do anything to create this perpetual source of energy. Oh. Your explanation is pathetically incomplete. All right. A planet is constantly being bombarded with force, and yet it doesn't collapse. Why would it collapse? It's pushing back. It's compressing the matter. You don't understand how when you compress something, there's only so much you can compress it, and that's it? There's some fluids that are incompressible. Water, for example. You don't understand that as a concept? That once you smash these little bits close to each other, there's going to be a bunch of stuff between them reflecting and creating pressure between them. That theoretically, if I could make two ping pong paddles and have a ball bouncing between them, there would be a point that the pressure would be so intense that I couldn't push it any closer. Duh. And is there every evidence that the Earth is pushing back? The fact that it's molten in the center, isn't that maybe an indication that it's full of a bunch of energy pushing back? Oh, amazingly stupid. Okay. Yeah, it doesn't collapse, and the energy has to come from somewhere. Exactly, it's coming from the fact that it's absorbed motion in two directions. That's why it's creating shadows. It's absorbing force. The force isn't getting where it's supposed to go because it's been absorbed by the material, and it's causing the little bits inside of it to move. And the Earth has stuff moving in these two directions. It has stuff moving in these two directions, and these two directions, and these two directions. In all the directions, it has absorbed energy. There are bits inside the Earth that are going this way, and there's bits inside going this way. And that absorption has heated the Earth and creates pressure, always pushing in all directions, going out. Because it's absorbed the motion. Okay. It came from somewhere, and you never explain where it comes from. So that's just a gigantic lie. So, I mean, of course, I'm explaining that it's coming from the same place the cosmic background radiation is coming from. Have you ever asked a physicist, where does the cosmic background radiation come from? No, you don't bother, right? So it's just a matter that you're just being, again, you're just being a troll for a religion. You're trolling for Jesus. Okay, how do the Twans know what frame of reference they are in? Well, again, there are no frames of reference. That's your baby talk. Okay, there's one universe. Everything's in the same universe. The universe doesn't get smaller and bigger in different places. It doesn't have different shapes. It doesn't do any of that thing. There's the same laws involved. Every little bit of every little photon that's in space isn't warping and, you know, going through all kinds of bizarre space. No, it's dead, quiet space, and you either hit things or you don't hit things. Everything moves in straight lines. There's no bent geodesic making things complicated. That's all your fantasy and your delusion that you haven't proven with any credible evidence. Okay, does the invisible God frame tell the Twans where they are in space at all times? No, they exist in the space, and they move through the space, and they don't need anybody to tell them anything. The space is rigid, the rules are rigid. It's not your little fantasy world, Jerry. You're confusing science with philosophy of science. Bullshit. There's only science. Philosophy is a subcategory of science that deals with issues that don't have physical evidence. Physics is physical, evidence-based. Philosophy, obviously, you have to base your arguments all on kind of circumstantial and, you know, the illusion of consciousness kind of stuff. Your hypocrisy is you what to pass for your theory. Your hypocrisy is you want a pass for your theory because my sole task is to create a model that fits the evidence. There, so he sat there and he quotes that, and again, but he won't prove that there's some experiment that proves otherwise. But then you turn around and say the real physicist, whatever that means, need not only create a model, which they have done, and unlike you, they have done so successfully. In what way has it been successful? In what way have they gotten to anything fundamental? You keep arguing that everything is dependent on this silly quantum mechanics or some other thing, and that invented something. Didn't invent shit. Just understanding relationships, like, oh yeah, the slit, if you make the slit wider or less wide, it changes the pattern. That's the only knowledge, okay, that advances things, that knowledge. Not any one of your fantasy rules. You show me where a bent photon did anything ever, okay, that advanced any science ever, anywhere. There's no bent photon theory that's created any advancement in technology. Unlike you've done, but also that they must explain why every facet of their model works. Well, yeah, I think that's the obligation, is to recognize when it doesn't. And you fakers and phonies aren't recognizing when it doesn't fit. You just don't care. You just play a game and say the math is perfect when it isn't perfect. You play a game that somehow the pattern in the photon experiment is this lovely wave of on and off when it clearly isn't, and you just pretend it is. You'll say the galactic lensing images are Einstein rings when they're mathematically impossible, they're not symmetrical, they're got globs of detail in them that shouldn't be there, but you shouldn't be able to see any of that stuff. They're not, tiny micromillimeter thick. Instead, they're thousands of light years across, all things that can't possibly physically happen by your own theory, and yet you're saying, oh yeah, no, our theory's tight, it's all well constructed. No, it's a pile of crap. Sorry, I'm not getting to the video apparently. There's going to be more than one video here. I didn't realize he typed all this shit. I'll explain why every facet of their model works, all the way down to the omega, the turtle, whatever that is. Well, obviously saying silly things like turtles all the way down is just people evading the obligation to explain something. And I think it's already kind of obvious that the two universes, the big one and the small one, aren't operating in terms of their properties. What emerges out of them is not consistent. You can't take what's out there and in any way say the same thing's happening down there. So it's not the same creature all the way down. There's only one universe. It's the little tiny one. That's it. Where all this little stuff is what makes everything happen. This is where the determinism is. This is where the mechanics are. Okay, the electrons, the protons, that's where the real game is being played. And all the rest of it is just what that does when you have a ton of it. Okay, that's duplicitous, and that's why people laugh at you. You're not people. You're people with no integrity. You're fucking cowards. Again, any one of you can anytime. I'll go on Skype and you can prove me wrong. You can demonstrate how I don't have good arguments, that I'm not making valid claims. Anytime you want, I'll take you on. I'll pay you if you have a degree, all right, to defend your physics. I'll pay you to defend it, all right? So there's no me. I'm not the one running away from it. And you're the one saying, oh, we're just going to mock you instead of making an argument. So again, no argument made here, no physics really presented, no challenge to anything I've said, no citation to the experiment that demonstrates me wrong, just more crap, trash talk from a bunch of religious kooks, behaving just like religious kooks. Completely invalid arguments and insults, and they run away. You're going to hell. Fuck you. My God hates you. Well, fuck you likewise. While we're still waiting for the computer simulation of the atom. Yeah, well, it's getting better and better. And again, so when that shows up, is that going to prove anything? No, you'll have the same stupid arguments, right? You'll weasel your way out of it. It won't make any difference to you. I mean, I've already pointed out the theory and how it's so obvious that it will work. I mean, You can't deny the ping pong paddle argument, can you? If the photon is perpetual energy, that you can never destroy the energy of the photon, the momentum, right? I mean, this isn't a complex understanding, right? If the momentum is constant and it always moves at the same speed and every single impact is exactly the same amount of energy, well, you can understand if the paddles are this far apart, the pressure pushing the paddles out is going to be half of what it is here. Now, is there some way that theory isn't perfectly reasonable, perfectly rational, fits perfectly with what we see when you watch two magnets repel each other? Does it look like something else? If you could just bend your brain just a little bit to imagine it for a second, and you imagined little balls bouncing between the magnets and realizing that yes, when they're north and north, there's perfect reflections each time, and as I bring the magnets closer together, I'm going to double the amount of pressure. Come on. You know, it's right in front of you, and here you're playing this game. No Nobel Prize for you. Well, you know, how you know, it's just unfortunate that there is no deserve in the world, right? Because what will be the deserve you get for your obnoxious, rude bullshit? I mean, you know, if I do win the Nobel Prize, I'll certainly point out in my speech that yes, all these assholes, let's go find them and piss on their graves. Okay? Because what else do they deserve? Right? They didn't care about science. They didn't care about the truth. They just cared about defending their fucking religion. A fucking religion. And that's all they had. They didn't show any integrity in the argument. They didn't make a stand-up argument. They behaved like sniveling little weaselly cowards standing behind rocks, hiding behind rocks, throwing rocks. No guts, no character, no integrity at all. So what should you get for your bullshit? If I'm proven right, what should be your penalty, asswipe? Alright. So we'll read this other part, but there's no point. Obviously, the problem for all this is that there are no more gunfights. Yeah, exactly. They're all cowards. If we still had gunfights around, they wouldn't be such pussies. I don't know if that's exactly brilliant, but okay. Yeah, well, yeah, how modern? Well, what is modern? Modern is we give people the right to spam, steal money, do all kinds of lying and conniving. We have no laws against it. People can lie, they can make insane fake news stories. I was raped, I was this, I was that. They can do preposterous lies. They can ruin people's lives. And what do we do for the liars? Well, we give them media attention and allow them to make money off their lying. So yeah, modern society is suck all the way down. No integrity at all. Most of you are despicable liars. That's why you give rights to liars, quite obviously. You're disgusting. There, done with that. Alright, so this was kind of funny. Oh, no, that's not the one. I mean, that one's stupid, but we'll save that one for later. Let's see. Software, who cares? Alright, I have a challenge for you. So this is the resident skeptic. Let's see what the hell that even is. See who he is. Alright, doesn't make any videos. Blah, blah, blah. Test chords, the little wing depths, the depths. I don't know what that could possibly mean, so not too interesting. Alright, got it. I have a challenge for you. Watch Nick Lucid's. Well, why don't you call him what his channel is called? Whatever it is. Stupid loony physics. But anyway, explanation. So again, I've already played like, what, 5 of his videos in the past and pointed out their inadequacies. And so yes, I'll play another one. What the hell? And come back and tell me why he's wrong. Well, I'm going to start making the same arguments. The wrongness is in the bold assertion with no real evidence, and the fact that the assertion is preposterous. Okay, there's magic space that tells things what to do, nothing space. And that somehow perception, you know, how you perceive the world means something. So I can say something didn't actually, two events weren't actually spontaneous because you're not positioned between them in this, you know, equidistant, and the medium through which you're going to understand when they happened is going to be moving a constant speed, and so you're going to know about one event before you know about the other event, and somehow that's a big fat mystery. it's not mysterious at all. Okay, it doesn't mean anything. Doesn't mean spontaneous doesn't exist. I mean instantaneous. Sorry, a lot of words to have to keep straight. So I'm just saying there's no evidence for your theory. There really is no evidence for it. And I explained how the whole Einstein thing with the bent light, and the fact that he decided he's going to make photons bend so he can make them look the same when they're not the same, when there is no real equivalence, and you can see the difference with something like light. And there is an actual force involved. And the forces don't interact with forces. Something they all should already know. Okay, just because that's what gravity proves and that's what charge proves, is that things don't react to each other's force. The force has to actually hit matter before something can know it's there. The flashlight can't hit flashlight beam. Alright, so off to the video. The antics.
This, Doc Brown and Marty have arrived from 1985, and it's the 100th anniversary of general relativity.
So this is from 3 years ago. Or 4.
Welcome to the Science Asylum. I am Nick Lucid. In a previous video, I gave you an overview of what Einstein had to say about gravity, and you told me 3.5 minutes wasn't enough. Remember, you asked for this. General relativity says that massive things will curve paths that would normally be straight lines. But that can be really confusing if you've never seen...
So when they always do these curves in these eccentric ways, these way exaggerated ways, which is sort of annoying. It's almost like the Earth's orbit is barely out of round. I mean, 3 degrees difference, something like that. And they always draw it like we're millions and millions of miles difference between, the two ends of the orbit. Like the ellipse is a huge, giant ellipse, when it's just a tiny bit out of round. I mean, it's just a little bit out.
Seen anything like this before. So let's start with a simpler question. What's relativity? To understand that, we really need to go over some history. It all starts in 1632 with a crazy Italian guy named Galileo. While he was busy sticking it to the man, aka...
Alright, so let's just understand. So Galileo was, a great scientist. And he thought about things, and he figured out this idea that you could be riding on a stagecoach, and, you could throw something, and you're throwing it at a speed. And that if you were to throw it out the window, though, it's going a different speed, seemingly, right? I mean, it seems like it's going one speed inside, but if it goes out the window, it seems like it's going a different speed. Now, it's going the same speed. The only thing that's different is the people outside aren't going the same speed you are. So from their perspective, it has not only the speed of the stagecoach, but the speed you threw it at. Where inside, all you see is the relative motion, the difference between the fact that you're both moving in a direction. Good observation, but it would be wrong to say, well, everything normalizes to your environment. So yes, me and this stuff is all moving around on the surface of the Earth and through the galaxy we have the same starting point, you could say, or finishing point. And then any new action, okay, is going to be relative to the condition we are all in mutually. So we're all doing exactly, hold them still, we're all doing the same thing, And now I'm going to create a difference. And so it's just the difference that we're talking about. And what's the nature of all these differences? And they're just differences, okay? But none of us got it for free. So they're sort of going to argue that... Well, I can't even explain what they're going to argue, because relativity, in the sense of pretending there's no real velocity, right? So they're kind of saying there's nothing in the universe going 0 miles an hour, and there essentially is nothing in the universe going what we know is the fastest speed, the speed of light, so a photon. So they're basically saying there isn't anything doing this real thing of actually having real motion. They're making some universe where motion isn't relevant somehow. I don't know. Because they're just change the warpy lines in the space to pretend if you're in these little tight lines, you're doing one kind of thing, and if you're in these big giant warpy areas, something else is happening. It's something like that. But like I said, you can't draw a picture of it. There's no rational starting point where I'm arguing that no, the universe is really simple. It's a simple mechanical place, and the idea would be is that you could understand that it started with equality. Okay, there was stuff going this way and stuff going that way and stuff going that way, and everything's equalized. And as you put stuff in this universe, what you end up doing is changing that equality by making something that moves much slower than the force move. And once you do that, then forces aren't going to be equal, because depending on how big the thing is that absorbed it, this thing's going to move much slower than this thing. Where things are going to intersect is going to completely change, and the universe changes. But the idea would be is that everything in the universe has to equal zero, in the sense when you add up all the lefts up and all the rights up and all the ups and all the downs and all the ins and all the outs, you started with zero pressure in a sense. They all equalized. There was just as much stuff going this way as going that way. And so all this motion in the end has to be equalized. So you could sort of understand that you spinning on the surface of the Earth, and then the Earth going this way in space, and then the galaxy moving this way in space, that all those motions effectively in the end, there's a probability. If you're collecting motion in this direction, the odds are there's a bunch of motion in this direction still left in the universe, right? So if you've collected a bunch of heads, you kind of know, well, there's probably a lot of tails out there ready to hit me. So now there's more tails out here, and the probability is that I'm going to be hit by some tails eventually. They're going to show up. There's always this equal number of them. And yes, for a while I can say, wow, I'm really collecting a lot of heads. But inevitably it's going to go back to zero. That's going to be your average in the end. And so when you add up all the different motions, it probably adds up to, yes, you're not going very fast. So although it looks like, if you start adding it all up as being motions in separate directions, if you add it up like, oh, I'm going 1,000 miles around the Earth, and I'm going 10,000 miles an hour through the solar system, and I'm going 100,000 miles through the galaxy. Well, if you add them all up in straight lines, yeah, it looks like you're really going very fast, but you're adding it all up. But the truth is these directions are all in different directions. At one moment you're spinning this way on the Earth, the next minute you're going this way, the next minute you're going that 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 way. It's constantly changing the directions. So all these arrows are going this way, and then you're adding this direction, and then you're adding that direction, and then you're adding this direction, and then you're adding this direction, and then you're adding, oh, look at that, you ended up back where you started. So they started with a model that says that's not right. Okay, that's not how it works. They start with a model. They didn't start with it, but they started building the road through the swamp. Okay, and then they just, once they were halfway into the swamp, they said, we don't want to go back and start over. That's no fun. We already got half a road through the swamp. So they just doubled down and then doubled down. So the swamp turned into a cesspool, and then it turned into a frickin', a bunch of quicksand, and it didn't matter how ugly it started getting. They just kept saying, we're too invested in this road, and they just won't let it go, because they've got way too much asphalt in the swamp now to start over. They're just never going to, well, not that they're never going to. Eventually they're going to be forced to, because the facts are just going to pile up and pile up and pile up that they started wrong. Having two different fundamental mechanisms, bent space and quantum mechanics, they're totally incompatible. And their explanation of movement and energy is not compatible. And they got a failed idea, and they're just going to keep doubling down.
In the Vatican, he suggested, amongst other things, that all physical laws should be the same in every inertial reference frame, or IRF.
Right, and so it's a reasonable conclusion for somebody back in the 1600s. It's just not a brilliant thing to say now, because we kind of know that physics is this little stuff. And, it is kind of silly to say it has no consequence, that we could move the stagecoach 30 miles an hour, or we could move the stagecoach half the speed of light, and the physics in the stagecoach wouldn't change any. None of the matter changes no matter how fast you make it go. That's illogical. And it's certainly illogical when we know the proof, in the sense that we know it's so difficult to start moving matter faster and faster. It gets harder and harder and harder and harder to move it. And clearly the only thing we ever can move is some kind of tiny, tiny thing, because anything big falls apart.
What's a reference frame? I guess that does sound like some complicated science thing, but it really...
No, it just sounds like, oh, okay, you're saying the universe is cut into quadrants or something. There's special little areas, little universes in the big universe, that it's not one universe with one set of rules, that you can have little frames where you can change the rules.
Really isn't. Typically, physics uses a coordinate system, or frame, to refer to measurements. So your reference frame is just the...
So that's sort of just a lie, because obviously their frames are a way of isolating one part of space from another part of space. So the frame doesn't have a fixed geometry. They don't believe in the fixed geometry because they don't believe in an absolute movement in that geometry. They think your movement is in some kind of pretend world, and then you can move that whole frame in some other world, and then you can move that frame in some other world.
Coordinate system attached to your body. It's your physical point of view.
Right, and there's only the physical point of view of the entire universe would be my argument. The universe is one place, and yes, the one place has locations in it, and they're real locations. The Alpha Centauri is really way over here, and we're really here. And there's no magical way that you can just pretend I'm just going to move the frames, and then they're right on top of each other. That's bullshit. That's just made up, silly talk.
What's it mean for that to be inertial? Physically, the word inertial just means that motion stays the same. So an inertial reference frame is just a coordinate system that moves with a steady speed in a straight line.
Right, and all the coordinate systems are in one reality. So if you're moving in a direction, even with a little friend, okay, the fact is that if there's something else over here and it's not moving, then you're moving and it's not moving, and all this relativity stuff doesn't mean anything, in the sense that there's something that's actually moving. So again, I could just go to their own silly stories about, people leaving on a spaceship and traveling light speed, and then aging 1,000 years, only 10 years in 1,000 years for the person that didn't leave, and how it's just a paradox, because they can't tell you which one is going to do the aging, because they can't say which one's moving. The other one might be just stopping. This one's already moving 10,000 miles an hour, right? We're moving like 20,000 miles an hour through the solar system or something like that. So why don't we just say, if we jump off the Earth, that we're going to, the Earth is going to end up going much faster than we go. We're slowing down, right? So the Earth should age much slower than us because we jumped off. Something like that. I mean, it's just nonsense.
But let's give this some context. Here we have Awkward M standing on the ground and Chauffeur Clone driving a car. Both have coordinate systems with steady motion, and both...
Right, and so this is just a simple Galileo kind of observation, but you don't need coordinate systems to understand it. I mean, the real frame you're in is the frame of the parking lot. That's the one you're really paying attention to. And you're just saying, relative to the parking lot, there's movement happening, and obviously one object is moving and one object isn't moving in the parking lot. That's the asphalt field. So you could say that they could, if they were in the whole universe, the argument could be made is the bystander and the parking lot could be moving. Now, it doesn't seem very realistic. Yeah, but okay, you could think it that way.
Completely agree about what forces are involved. The laws of physics are the same. This is a weird consequence, though. They don't agree on who is moving. Awkward M would say the car is moving, but Chauffeur Clone would say Awkward M is moving.
Right, and the only thing we lack is a true accelerometer, right, or a velocity detector. So we don't have some universal velocity detector. except for, okay, as Einstein mused, let's say, or speculated, the idea of a light clock. So again, if you could use photons, because photons are the reliable thing, they're a force, their movement is constant, so you don't have to worry about any relativity in the sense you've established that there couldn't be any consistency in the universe because you've measured this stuff going in all directions, and in all directions there's no relative problem. The photon always goes from a point A to a point B of a certain distance in exactly the same speed. So it's a very reliable, it's durable in the sense that it travels through the universe without any change in its properties. Its properties are fixed and dependable and reliable. And the property is it moves in a dead straight line is the rule. So if you could make a light clock, the idea would be is that you just measure how long it takes for a photon to go from one surface to another surface. Just watch the straight line. You don't even have to measure anything. You just watch where it hits on the surface. And so if you could just move this device, okay, at a speed, you'd be able to see that as the mirror moved, you would hit a different location on the mirror depending on how fast you were moving. The photons are reliable. They're always just going to go in a dead straight line from the point they're released. They don't care about motion in this direction. They don't care about motion in this direction. From the point that from their perspective, I've argued it's like a flying bird in a cage. If it never touches the side of the cage and it flies inside the cage, it's unaltered by any motion in a direction except for the fact that it starts flying more in that direction. So if I move the cage really fast, the bird is going to go from flying around in circles in the cage to flying exactly the direction the cage is moving if it's not going to hit the bars of the cage. Kind of a simple way of understanding it. So their argument is that photons, they don't understand what they are at all. They don't understand that it's indestructible energy and that all you can do is trap it. So this idea is completely repulsive to you people, apparently. So the idea that this force stuff, like a bird, could be trapped, that is, it could get caught in a circle, okay, and just keep doing that inside a matter, and then at some point it would be released again. And you're not releasing it, you can't give it more momentum. All you can do is change the shape of this circle. You start moving, you change the shape of the circle a little bit, but so you never changed its motion. And so you do is release the bird. If you release the bird isn't going to go faster because you were going faster. It's not going to be going slower because you were going slower. It's not going to do any of that. It can't care what you were doing. It's doing one thing. It's flying in a straight line at a straight speed, and it ends up, if you trap it, well, okay, then it's not the straight line anymore, but it's the same speed, and when you let it go, it's just going to let go wherever you open the door and wherever it is in its motion. And that's it. And so that's what photons do. They're reliable that way. So as you move, you'll see this line tilt down, okay, and I'm exaggerating it for the sake of the argument, but at half the speed of light, that's what you're going to see, a dramatic change. Now the problem is we just can't make one of these because to see the difference, because light travels so fast, you have to make this miles long, and it's really hard to do an experiment with something miles long and then move it somewhere move it fast to see this change. But in principle, this light clock solves the problem. If we could put the light clock in a car and we could put the light clock on the parking lot, it could tell us the exact motion we have while we're standing still, so to speak. And at every minute, I would argue that the light clock is going to, if this was your readout, okay, the light clock's going to do this, and in a millisecond later, it's going to hit this spot. And a millisecond later, it's going to hit this spot. And a millisecond later, it's going to hit this spot. And it's going to do that all throughout this whole thing. And guess what that's going to create? It's going to create divergence. That is, it's going to make it look like the laser beam is doing this, okay, that's spreading onto a big surface, when no, actually it was just going in a straight line, but it will not obey your will to hit one point because every single second we're moving through space, our acceleration is constantly changing. Your absolute motion is constantly changing as the Earth rotates, as the Earth goes around the sun, as the solar system moves through space. Those accelerations mean your force that's hitting you is changing, and it's happening, every billionth of a second. There's a little more heads from this direction, or a little more tails from that direction, or whatever. You're constantly moving with the changes in the forces that are acting on you. So that's the liability of it. But the principle is clear. That would work. If we had light clocks, we could solve all of these problems, and we could see exactly who's moving and who's not. Who's moving faster, or who's moving in what direction.
No. Awkward Emma's on the ground, so she's the one that's sitting still, right? False. The ground is moving due east at 770 miles per hour since the Earth is rotating. The Earth also goes around the sun at 65,000 miles per hour. I could go on, but I think you get the point.
Yeah, I know, but you see, you should theoretically go on, okay? And then figure it out that where does the motion come from? The motion comes from interactions with force. Photons hit you, they push you. Okay, other instruments that have motion in them hit you. Meteors hit you. Some kind of thing hits you, and we know that transfers motion. That gives you velocity. You could sort of understand that. Well, if I took one piece of the Earth, just a little piece, an atom, that I could trace its history. Theoretically, it has a history. All right, and eventually I could trace it to some explosion where it flew out. And then forces acted on it, gravity and other things, and changed its path and made it coalesce, end up banging into other atoms, and then those atoms banged into other atoms, and that the motion came from somewhere. The motion isn't something you just have, or that you have relatively. You gained it through physical processes that took place in the universe. The velocity has a history. If it exists in something, it has a history.
Point. The important thing to understand here, it's not just that you can't tell who's moving and who's sitting still. Inertial motion is relative, which means both Awkward M and Chauffeur Clone are correct.
Right, but all of this doesn't really have anything to do with relativity. So he's premising the argument with a description of things that are commonly seen. It's the baseball thing, and it works. But the trick is photons aren't baseballs. Photons don't collect two momentums. You can't change the direction they're moving while you're throwing them. It's like an astronaut in space. He's orbiting around the space station, and he's two astronauts, and one wants to throw a wrench to the other one. Well, he throws it, one way. He thinks it's going that way, but he doesn't really, because the motion of his velocity is already being built in when he's throwing the wrench, and the wrench will actually leave in a direction he didn't even intend to throw it. I mean, that's the practical fact, in the sense that the two motions will be added and create a third motion, a net motion. That's when relativity starts getting complicated, is when you realize photons can't do that. Photons don't care they can't combine two motions into a net new motion. A photon doesn't do that. Well, a new velocity. I should have used the word velocity, actually.
All measurements of motion are correct, even if they disagree. That's relativity. And it's not just limited to the motion of the frames. If Chauffeur Clone is driving at 20 miles per hour and then throws a ball at 30 miles per hour, Awkward M will see the ball moving at 50 miles per hour. But the clone only sees the ball moving at 30 miles per hour. But how does Einstein fit it?
So again, sees it. Again, so this is just perception. They're talking about what you see, not the physical fact. And the physical fact that that the thing is standing there, that's not a car moving 30 miles an hour, obviously would see anything that happens 30 miles an hour plus the new motion. So it's not at all mysterious.
All of this. Okay.
But the thing is you can't make photons do that. Photons don't obey that rule.
This kind of relativity is called Galilean or classical relativity. It's another 273 years before we get to Einstein. There's way more timeline to go through. The story is important, okay? He solved a major problem
It really isn't. You ought to just get to the theory instead of blaming it on other people that made likewise mistakes. But I mean, the point is it's Einstein's fault, okay? You fell for this mush. So why not get to exactly what he was talking about and get to this silly notion that because a light clock in space will do exactly what I said by Einstein's own theory. Okay, Einstein believes the light will bend down. It'll appear that way. It'll look like the photons bent down. Now, they never did, but it'll look that way. And then he made photons on Earth and gravity do the same thing because he wants to say gravity's the same force as the rocket engine. And it's not the same force. It doesn't move into the objects in the same way. It's a different force, and it will produce a different result. You won't see, gravity won't cause, okay, the motion being created by gravity won't cause the same effect because the Earth isn't moving up.
173 years later. Back to the timeline, crazies. So, 1632, relativity was born. And then Pope Urban VIII put Galileo under house arrest for the rest of his life. From 1660...
Well, obviously that wasn't the reason, but whatever.
5 to 1667, Cambridge closed due to an outbreak of bubonic plague, and a rebellious undergrad college student named Isaac Newton was sent home. That gave him the free time to develop his law.
Well, he was sent home or he ran home. I mean, you know, if you're going to tell the story, at least concede that sent? I don't think so.
Of motion, calculus, some optics stuff, and his universal law of gravity, which was far from universal even then. He published none of it until 1687 because he didn't want anyone else to know how to do it. Selfish doo-doo head. Anyway, everything was going just fine until some jerk-face named James Maxwell showed up in 1865. He discovered that not only was light an electromagnetic wave, but also that this meant that the speed of light was a universal constant.
Right, that was found out before Maxwell's equations, and so they already knew that their two fake constants added up to the speed of light, because that's why they made the two fake constants, the numbers they made them, because they bisected one force into two forces, and they made two fake constants, the electric constant it's called now, and the magnetic constant. They're two constants that were never measured. They were only deduced through mathematics, in the sense that obviously the force does in fact move the speed of light, and the only way you can account for it, okay, is to in some way, if you have two equations that are saying one force is two forces, well then obviously you have to bisect it. If you're going to put in your equations a B field and an E field, well that would add up to 2 times the speed of light, so you have to cut them in half essentially to create separate little fake constants. And again, they've never been measured.
What? Yeah, this is a serious problem. How is that a problem? Sure, maybe if you only think about it for a second, you're like, meh, whatever. But we don't do any of that shallow thinking here in the asylum. Asylum crazy.
No, it's not shallow. This isn't shallow. No, not at all.
This thing deep. Remember Awkward M and Chauffeur Clone? Awkward M would say the car is moving, but Chauffeur Clone would say Awkward M is moving. Remember, both...
No, it really wouldn't, okay, if they had some way to measure movement that wasn't a sensation. Again, I fall down the well, all of a sudden I lose my capacity to know that I'm moving, okay, by gravity. Now, you're going to claim in some sort of fake space that the Earth is moving away from me, okay, as I'm falling down the well. I mean, it's a nonsense idea. We do know which way I'm going in absolute space because the planet Earth is providing us with evidence of what absolute space is doing, and relative to absolute space, I'm clearly moving towards the center of the Earth, and theoretically I can't really do that unless the Earth isn't in real space and all the atoms inside the Earth aren't in real space, but they sort of have to be because they're all not on top of each other and they're not blurring as individual objects. So this is just crap. So because our sensations don't tell us when what exactly is acting on us every second, that somehow we should pay more attention to our sensations than what we can physically understand, what we can model. And the model tells us the truth.
are correct. That's relativity. And it makes perfect sense if we're talking about a ball. But what happens if we try this with light? Say you're in a spaceship zipping past my space station at half the speed of light, and then you turn on its headlights. You would see the light move forward at the speed of light. But do I see it move forward at 1.5 times the speed of light? No. I also...
Right. And that's, again, it's demonstrated by Einstein's own experiment. He doesn't have the light in the spaceship and the light clock moving forward. All right, it doesn't magically jump forward and hit the surface, where it's supposed to. He concedes that the spaceship moves away, the light is a constant, and the light is going to hit lower because you move the surface the light was supposed to hit. And so we know what surface moved.
Also see it move forward at the speed of light. The speed of light is a universal constant, so everyone has to measure it exactly the same, no matter where they are or what they're doing.
Right, and what do you mean by measuring again? So if we could actually see photons, well, that'd make it a lot simpler, right? But the only way we can measure it is by how fast it gets somewhere and it hits it. So obviously if we're moving towards an object and we're shooting light at it, well, as we're getting closer and closer, the time it'll take the light to reflect back to us is changing constantly. And so we're going to have a different impression about how far away the target is, right? So at 1 second we shoot the light and it says I'm 5 miles away. The next minute I'm closer, so it's going to be 3 miles, and then it's going to be 2 miles, and then it's going to be 1 mile. I won't read it the same way because I'm getting closer to the thing that's telling me, that's the reference. And it's just nonsense not to say that clearly from 1 mile away the light will seem, that it's reflecting much quicker than the light from when I shot it from a long way away. And I can understand that either the thing is moving towards me or I'm moving towards the thing. But I mean, those are going to be differences you can see. The time it takes for the reflection to happen, the echo, the echo in a small room versus the echo in a big giant room, you can see, feel, test the difference.
Houston, we have a problem. Galileo says all motion is relative, and then 230 years later, Maxwell's all like, well, not for light. So now we have two competing theories of motion. Is Galileo right? Is Maxwell right? The debate raged on for 4...
Well, I mean, obviously both of them are a bit archaic, so both of them didn't know what an electron was. So, I mean, how can you have this conversation even? I mean, it's almost ludicrous to sit there and say, are they right, when they didn't have complete information. I mean, Galileo obviously couldn't do these experiments because he couldn't understand. He didn't know there was a speed to light. He thought maybe it's instantaneous. So why would it even worry him about two events that are simultaneous, right? He wouldn't have any problem with that because, frankly, he'd say no matter where I go, no matter how close or far away I get from the two objects, I'm going to know about them instantaneously, so they're always going to stay instantaneous. He's not going to have any problem. But the fact that light does take time is news. It's big news. The fact that light has a speed kind of indicates that it's a thing that really has to go somewhere, that it's not some sort of magic. And the fact that it's carrying momentum sort of indicates, well, maybe that's why it takes it time to get somewhere, is because it's something, not nothing.
Decades. Suggestions of universal reference frames, measurements of the speed of light in multiple directions, and
So again, there's multiple directions. They didn't measure the speed of light in multiple directions in any other way than to say that somehow there's some ether that's going to make the force move slower. When you can already deduce that's kind of nonsense, but you can't make the other forces move slower, right? They didn't quite have radio waves then. Well, maybe they did. Well, anyway, we're just saying that lots of things we understood, you couldn't change them. You couldn't change how fast the magnetism moved and these other forces. And yes, you could change by having a thick liquid versus a thin liquid. You could change how fast things get through those kind of materials. And you could change how fast even light gets through things. So there was some indication that everything is medium-based, and so they just turned the universe into a medium. And at least those people, Michelson Morley, had the guts to call it something, an ether, And by the time of Einstein, they decided, well, let's not, ether's an ugly word. Let's not use that. Let's just call it space. Let's call it something else. But really what they're saying is that there's some sort of jello that everything has to migrate through. And there's no reason to believe any of that.
And finally, in 1905, Albert Einstein showed up on the scene with 5 papers. Measurement of the mole, Brownian in motion, photoelectric effect, E equals mc squared, and a crazy but brilliant suggestion for our problem. What if Galileo and Maxwell are right? The only way they can both be...
Yeah, what if contradiction is okay? So let's play contradiction. Let's have wave-particle duality. Let's just forget about doing logic and logically analyzing, and instead just say, nah, screw that. Let's be irrational.
Right is if we're wrong about everything else. Completely wrong? No, just a little wrong. If the speed of...
Well, it's actually a lot wrong, but regardless.
light is the same for everyone, then nearly every other measurement must be relative. Time, distance, length, energy, momentum,
So again, all these other things, okay, should be constant. So time is a real thing. It's the amount of time it takes a photon to get from point A to point B. That's fixed distance. It's perfectly reliable. And they're playing this game like it's some wacky dimension that you can warp and bend. No chance.
must all depend on your point of view. We call this Einstein's special theory of relativity.
Right, and all this point of view thing just comes down to the fact that because light moves at a slow speed, something slower than instantaneous, therefore we're going to pretend that when we get information is when the information was created, when that would be really stupid, right? Because now we're smart enough to know, oh, it takes time for light to get where it's going, so when we receive it, we should already know, oh, that really doesn't have anything to do with the facts.
Or just special relativity for short, because it only works in a special case. When you're taking measurements in an inertial reference frame. If you want to take measurements in an accelerated reference frame, one that isn't moving steadily in a straight line, then we're going to need a more...
Right, so I would argue that that's a backward way of looking at it. Clearly, the two theories are about two different things, but one of them is saying general in the sense that it doesn't matter whether it has velocity, okay, or whether it's accelerating, that the two, that any motion is motion, okay, so it doesn't matter whether the motion's causing you to move faster or the motion is something you already have acquired. And in a sense, it's basically saying that any time dilation is going to be affected not by your velocity, by something specific like acceleration, that it's really being caused by absolute velocity, that your real velocity is going to dictate your time dilation. So in the twin experiment where you send a twin off into space and one stays on Earth, one of them really does move more, goes more speed, and one of them goes less speed. Okay, so you just can't, it doesn't matter whether you say the planet moved, okay, and you moved in the opposite direction and therefore became zero motion, so you didn't age because you left, and this one, well, you weren't preserved, okay, because you're preserved by motion. And so the theories, so if the two twins, this one's on the Earth, and the Earth was moving, and you moved in the opposite direction, and therefore undid your absolute velocity, and now have less velocity. So you're the twin that's going to get old faster. Okay, you're going to be 100 years old, and this twin's only going to be 10 years old, because this one's on the moving thing, even though you thought the other twin was on the moving thing because it left in a rocket. But it left in a rocket going exactly the opposite direction to your primary motion in some other direction. So there's their paradox, right? Their paradox is they can't tell which one, they can't explain anything, they can't say anything. But Einstein's theory is basically saying it's one or the other. Okay, the actual fact is one of them gained velocity and one of them lost velocity. And the one that gained velocity is the one that's going to time dilate or cryogenically kind of freeze. Okay, they're not gonna live more life. They're just gonna live their life slower. That's it. They're gonna move slower and do everything slower, and the rest of the world is gonna look like it's going really fast because they're going really slow. I mean, you can see these paradoxes in different, even like Star Trek had one where people moved really fast. It didn't make any sense. But you run into all kinds of paradoxes that don't make any sense. I mean, it would take years for certain events to take place, and they don't explain, well, what were they doing for years while they were waiting for that to happen? It doesn't make any sense at all, really. So the general theory is basically saying velocity, okay, whether it's from acceleration or whether it's something you already have, that's what's dilating your time. So the satellites in space, although they appear, okay, to be going really fast, right, 20,000 miles an hour, and most people have the dopey notion that this is the truth, okay, that somehow they're time dilated, that their clocks are going slower, when in fact their clocks are going faster, okay? And we'll use the opposite symbol for slower. And the guy on Earth, okay, us on Earth, we're the ones going slower. That's what general relativity says. That's what the outcome is. And the reason why they say that is because, well, it's gravity, right? This is the acceleration. So we have an acceleration down. This one's being accelerated much less by gravity, and we're being accelerated much more because we're on the surface of the Earth. But it's even more complicated than that, because what we're doing on the surface of the Earth is we're accelerating down, but we're also being pushed back up. And we're being accelerated down, we're being pushed back up. So we're traveling a very crooked line on the surface of the Earth. And so even though we say our velocity is whatever, 2,000 miles an hour, or whatever it is on the surface of the Earth, we're really going, much, much faster, because we're doing all of this in what we're calling a straight line. And so obviously we're moving a lot faster than it would appear we're moving just going around the Earth. Going around the Earth, going up and down. So it's like the speed of the basketball versus the speed of the basketball player. And so that's why our clocks, okay, are running much slower. Not much, but this is the GPS argument, by the way, assholes. Okay, so all we have is evidence that velocity is correlated. Now the fact is that Einstein's equations don't perfectly work, okay, so they don't figure out the GPS by doing Einstein's equations to figure out how to fix the clock. No, they fix the clock because they can synchronize the clocks merely to make it zero, to make them both zero, both of them, so they can know exactly how much they have to compensate for any particular satellite, because they just compare it to what they know the actual time is. And so they just adjust them. They don't bother doing Einstein math. They just adjust them until their readouts of like what a location is gets better and better and better. So as their trajectory to telemetry comes up with an answer of where the location is, they have locations that they already know are right, and so they just sit there and adjust the clock so their location is in the right place. So they just turn the knobs to get the right answer. They don't bother doing Einstein calculations because the Einstein calculations won't work. They won't come out right. They'll come out close, or they'll be somewhere in the ballpark, but they're not going to be right. And lots of GPS people have pointed this out. I mean, the dissident science guy had a guy who demonstrated essentially that yes, this is the way they do it. If they did Einstein's equations, their satellites would be less efficient. They adjust it anyway. But the point is yes, I'm agreeing. There's a correlation between velocity and how atomic nuclei decay, and how clocks work. Clocks break when you move them. Lots of them break. And the only one that won't break is the light clock, but we can't make light clocks, so to do these slow motions. So we're out of luck. So we don't have any indestructible clocks in the first place, but each clock's going to be broken a different way and a different amount by motion. And I would argue that this is all part of the fact that they don't even know what nuclear decay is. I would argue it's some kind of probabilistic thing. So I could make this as a theory. I'm just suggesting this is one possible explanation for how decay works. Decay works in that this improbable event has to happen. Force has to come in this way, and a force has to come in, say, this way, at exactly the same time, and they have to hit exactly this middle position. And when that happens, this nuclei splits in two. Okay. So you know it's a little tiny opening here and a little tiny opening here or some kind of bullshit like that, and the thing has to go right into that little tiny opening and blah 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 blah. So like a Luke Skywalker thing hitting the little thing, except two people have to do it from both sides of the Death Star at the same time. And the catch would be is, say if this object starts moving, okay, it gets really easy to get this ingredient. You're getting this ingredient a lot more, right? The one coming this way. But you're getting this ingredient coming from the other direction. Now you're getting that one a lot less. So the probability of you having this event starts to decline, you know, because you just don't have the circumstances that make it happen as often. So now stuff doesn't decay because you're changing, okay, the conditions that make decay happen. Okay, the improbable event is now made more improbable as you give this object absolute motion in space. And again, it's absolute motion. There's no denying it. The twin example points out that regardless of the relativity nonsense, the only thing that's going to actually make something different, it's going to make this twin different than this twin, is their absolute motion. People should be able to reason this out without my help. Gosh. Anyway, continuing.
General theory of relativity, or general relativity for short. But we have a minor issue. Physics isn't built on the things that are relative. It's built on the things that stay the same, like the laws of physics.
No, it's built on the difference between things, and nothing. That's the first step. The first step is to recognize there's things with momentum that are moving, and there's nothing that's not doing anything, that has no substance and no material existence. And that's the starting point. Not this relative crap.
It's between reference frames. We're quickly running out of things that stay the same. Einstein solved this problem too, but it took him another decade. What happens in accelerated reference frames? Let's take a look at one. Are you sure you've got this? Yes, I got this. All right. Let's say there's a ball hanging from a car ceiling. When the car is sitting still, the ball hangs straight up and down.
So let's understand there's no force that's going to act on it in any direction, right? It's not attached to the car. So the car motor can't be relevant to it, because the only way it can know it's in a car or that it's attached to a motor that's going to do something is through this little string. There's no other way for it to know. There's just no other way for it to know. Okay, the air moving in the car isn't going to be, its air is very compressible, so the air is going to compress, it's not going to move. So it's not going to have any way to know, oh, you moved the car, except through this little string. It's not a good source of information. It's not a good source of, you're going to come with me. Now, if it was a steel rod, well, then the thing would move right along with it, because the force would be transferred right through the steel, right into the ball. But there's no good transfer here. There's no way to transfer the force going this way, okay, to a string going this way. It's really hard to do that. All right.
Force of gravity pulling down and a force of tension pulling up. If it accelerates, the ball...
There. So, yes, the ball doesn't move. Okay, the ball's saying, I want to stay where I am. And the only thing it's going to do is it's going to appear that it's moving upwards, just because there's this string on it. I mean, it actually does move upwards, but I just mean the reason why it does that is because you're changed the angle. You're now doing the diagonal thing on the checkerboard, right? You went from doing diagonals to going straight lines. The line gets shorter. So you're just forcing it to move up, because it's not moving up. It's just moving, well, that's all it's doing. It's moving up. It's not moving this way or that way. It's just staying where it was, and it's being forced to move up because you're moving the string away from it. You're making the string essentially shorter by moving the string, right? The string isn't getting longer, so the string is moving away, and the ball is attached to it, and the ball is saying, well, where do I have to go? Well, I have to go up, because I'm stuck on a string of a certain length, and I can't go any... I can't make the string longer, so I can't stay here, because then the string has to get longer, right? I mean, that's just too obvious, right? This distance is huge compared to this distance. So obviously it has to go up to make the string shorter, because the string is going to move it up.
Swings toward the back of the car. Awkward end.
So again, The ball doesn't go towards the back of the car. The ball in its absolute space, in its real universe, the only thing that changed in the ball's universe is it went up. And it will start to go that way because the string only has a certain length.
Who's standing outside doesn't see anything all that strange. The car is accelerating forward, and the extra tension is what also accelerates the ball forward. So everything makes sense. In the car, we have a problem. Everything in there looks like it's sitting still. There's no acceleration. So the only explanation is there must be a new force on the ball. So what's the new force?
Okay, so again, there's no new force except the force that goes through the string. And the force going through the string is just saying this way, towards the string. You have to move towards the string, the point A and B of the string. The string is dictating where the ball is going to go. The ball has no other connection to anything. It's quiet. And the only thing that can tell it what to do is the distance between the point A and B of the string, and that has to change. Obviously, as the point A moves away, the point B has to move with it.
In all my merry-go-round videos, I called it a fictitious force because it doesn't exist from all points of view. It exists inside the...
Well, it exists for the ball. The ball knows it's attached to the string. The pressure on the connection to the ball and the string, if you made that connection really tenuous, so if the ball's standing still and the car's standing still, and you make the tension of the string just so any extra pressure would break the string, then that's exactly what you'll do when you speed up the car. The string will break, and that's it. So the ball's going to feel an extra pull on the string, and that's it. It's nothing magical, nothing complicated.
Car, but not outside the car. A force is just an interaction between two or more objects.
Again, so more bullshit. It's not just. That's the most basic element of the function of the universe is how force is communicated. And your theory of force is, in the big universe, there's a bent geodesic, and in the small universe, there's something called virtual photons. That's their theory, okay? That they're two fundamentally different things. There's bent space telling everything in the big universe where to go, and in the small universe, there's something called the virtual photon that's carrying, it's a force carrier, right? So he uses this word, force is just blah, blah, blah. No, force is a real thing. It's obviously a real thing, and there's a thing that makes force go from one place to another. It makes energy go from one, momentum travels from point A to point B through this very mechanism of the thing called like a photon. Not a photon, but something like a photon that they don't know where to account for it because they don't have a proper energy equation. So because they don't understand that the universe is pushing everything together with a real force made of real photons, not fake ones, but real ones. They just happen to be invisible, like the cosmic background radiation was. There's real stuff hitting us from space all the time. That's the force. And you can block the force with objects that have mass. You can capture it. You can absorb it. And then it doesn't get where it's going. And then that means you'll have an imbalance in your force.
The tension is between the ball and the string, and gravity is between the ball and the earth. But where does this new one come from? It doesn't appear to come from anywhere, so we call it fictitious or fake. But is it really fake? Also,
yes, it's really fake because up and a shorter string means you're doing the shorter string. It doesn't have anything to do with the fact that except all of it's in the direction of the tension of the string.
why are we treating inertial frames like they're more real than accelerated ones? Shouldn't everybody be on equal footing either way? These are very good questions, and the same ones that Einstein was asking himself. Back to the timeline. So, 1905, miracle year of physics. A couple years later, good old Al started really thinking about acceleration. It occurred to him that if you were inside a spaceship accelerating at 22 miles per hour per second, in a shake-proof, soundproof room with no windows, it would...
Yes, that's duplicating gravity, right?
Feel exactly as if the spaceship was sitting on the ground.
Right, because how do we know there's gravity? Is because the ground is essentially pushing us back. It's stopping us from going 22 miles an hour, okay, and we feel that. So being stopped from going 22 miles an hour is going to feel exactly the same as being pushed 22 miles an hour. Those two events are exactly the same. It's a change of 22 miles an hour. I'm being changed right now. Gravity's pushing me 22 miles an hour, and the fact is the ground is stopping me. And if you wanted to push me, okay, sitting in a chair, and you pushed me up at 22 miles an hour, I would feel exactly the same pressure that I feel sitting in this chair. I mean, that's not complicated at all. There's no mystery to it at all. But to argue that the force of gravity is behaving the same way as the Earth pushing me back, which is the Earth is only contacting me in certain locations, that's the fact. And if I'm going to be pushed in a spaceship, I'm only going to be pushed from certain locations. The energy has to go through my body that way, where the counterforce of gravity is pushing my atoms, it's pushing my electrons, it's pushing my protons. It's not pushing me from one place and placing pressure on the surface of my body. It's hitting all the elements of my body, most of them, let's say, and causing them to accelerate, the little bits. So I don't feel it. Because it's not confined to little pressure points on my body. Gravity's not a feelable force because it doesn't use chairs and it doesn't use feet. It doesn't apply itself like a string on that ball. It's not one place that it's pulling on. There's not one location being stretched or being poked or any of that stuff. It's poking everything, essentially.
Is the equivalence principle. More often than not in physics,
Right, so again, I'll argue a silly principle, a silly place Einstein should have never gone. He should have never pretended, again, that this, I mean, I really shouldn't have to draw it, but, you know, you people are pretty dumb, so I do have to draw everything, apparently, and I have to, you know, talk really slowly and try to make you understand. Okay. So my argument is, so he's saying there's this equivalency, but the equivalency of the two forces you can sort of understand. So I'm sitting in a chair, right? Human being sitting in chair, okay? And the force of gravity is doing this, okay? It's pushing, it's going through me, and it's hitting everything inside of me. I mean, it's tiny little raindrops. I mean, the thinnest little, tiniest rain you could imagine. It's so fine, and it's hitting every little atom and hitting every little electron, and it's moving all of them at once in this direction. So it's hitting at the speed of light. So I can't tell the difference that, oh yeah, it hit my foot slower than it hit my head. I can't tell any of those differences because it's happening so fast, and it's happening to every little bit inside of me at the same, essentially the same time. Every little bit is being moved. So you can understand, yeah, how the hell can I feel that? Okay, there's no pressure point. It's like 0.0000 pounds per square inch, right? So how do you write the inch part? All right, it's a tiny amount of pressure that's being applied to each little element of me. I mean, this is more like times 10 to the 40th or something. I mean, it's a it's a preposterous lots of zeros in there of pressure being applied to each little element of me, where here there's a big giant amount of pressure here. There's like 10 pounds per square inch here, and you know, on the floor, well, you know, there might only be 5 there because of the, you know, dispensations that my feet, you know, are less massive and blah 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 blah. But the truth is the reason why I feel it is because all of the pressure is being focused on one part of my body and has to spread through all the rest. It has to push. All the other atoms have to be pushed by atoms banging into atoms, and atoms banging into atoms, and banging. So I feel the pressure, where I can't feel gravity because it doesn't hit my neurons, my little sensors. Okay, it's moving the sensor the same speed that it's moving all the stuff. So my sensor can't detect it because the sensor isn't going to be severely banged into by the force. There's no sensor on my body that can detect the tiny little bits of force that are going through me and moving me. So why would I bother saying this equals? Why would I say this force is the same as this force? One of the forces has to smash into me and go through all the atoms to get to me, and the other force is doing something fundamentally different where it's going into all the atoms and creating the movement. I mean, they're different things. Why call them equivalent? Why waste time saying it's the same thing? It's not the same thing. And light doesn't bend.
Two things are indistinguishable, then they are exactly the same thing. And it's not just limited to spaceships. Remember this ball hanging in the accelerating car?
Again, that's a statement right there, right? If that's scientific, if two things are indistinguishable, they're exactly the same. So just because I can't tell the difference between this color green and some other subtle little different green, and especially on certain backgrounds, that means they're exactly the same. Even though I can prove they're not the same. I mean, I can do tests and prove they're not reflecting the same light. They're not doing a lot of things that look the same. So he's just basically saying because it looks like, it is like. This is just such a fundamental flaw in their scientific method. It looks like, that's good enough for me. That's all these scientists are saying. It is close enough. Okay, it's exact. It looks anything like something. It's exactly like something. I mean, this is just so fundamentally illogical.
Yeah, that fake force is actually gravity. There's now a gravity pulling down and another gravity pulling backward.
There's no other gravity. So again, all you've done is change the direction because you've limited the ability of this rope to stretch, and that's it.
So the total gravity points this way, which kind of defines the new down. It isn't any different than if the car was sitting on a hill. Same exact physics, therefore same exact thing. Wait.
Okay, so it did it again. And again, the whole point of the motion is that the object is got to translate, and the only translation point is that string. The string is going to decide where the ball goes, nothing else. All the motion of the rest of the ball will be dictated to by what the string connector does. If the string connector does something, the rest of the ball will do it. There's no other force acting on it. Except for gravity, of course.
You said that new force was...
Gravity doesn't change. The only thing that changed is the string. The connection point to the string. That location has to move, therefore the ball moves. Period.
Fake. If it's actually gravity, doesn't that make the gravity with the Earth also fake? Yep, gravity, not a real force.
So again, they say things like this, and this is their lame, cheap, superficial evidences of these little word games they're playing. These little word games. You know, it's not a real force. Just like the velocity that makes one of the twins age isn't a real velocity. Well, yeah, it is a real velocity. One of them will actually be going faster than the other. That will be an actual fact. And they pretend, oh, it's arbitrary. You can decide which either way and the same result. No, it can't be either way and the same result. It has to be one way to have the result. Oh, this is so bad.
How does an acceleration in one frame look like a force in another? For that, back to the timeline.
Yeah, back to the bullshit of not paying any attention to the fact that the information we gain at a speed. And because of that, two things that are different distances will get information at different times. Not a big surprise.
In 1908, a guy named Hermann Minkowski invented a 4D frame called spacetime. Einstein wasn't a fan, but by 1912, he knew his own approach wasn't working, so he had no choice but to accept Minkowski's. The math was a bit beyond him, though, so he consulted some of his math friends. And in 1915, he finally...
Why do we need any? Like, again, this not that it wouldn't be nice to have history, but we know this is all mush history. You know, that it all depends on who's telling the story of who did what and who was what kind of person and who, you know, gave credit and who didn't give credit and all this horse shit.
Figured it out after collaborating with David Hilbert. General relativity was finally a thing. The solution? Some accelerated reference frames are inertial reference frames. Before you freak out, let's review. Remember, physics isn't built on the things that are relative. It's built on what we call invariance.
So again, that's exactly the point. It's not built on anything real. Your physics isn't physical. Your physics is just woo and completely wrong understanding of the mechanics. That velocity comes from nowhere. It comes from some sort of space geodesic bending. That it isn't require something to collect force and then emit force in a direction. I mean, it's just terrible.
Those are the things that are the same from all points of view.
I mean, you can just sort of understand that the law of conservation that we see reliable all over the place, it tells us it's all conservative. You know, the whole universe has to be conservative, right? That there's just as much stuff moving this way as there is this way, and that way, and that way, you know. And that's why things do end up round, and that's why a lot of things happen, is because of the fact that it has to be conservative in the end.
Make a couple lists. I love lists. Relative things, length, distance, time, mass, energy, motion, the list goes on. Invariant things, the speed of light, space-time paths, electric charge, and I think that's it.
Well, if you're going to say there's a magnetic field, it's pretty invariant also. So, I mean, anything connected to the speed of light. So, again, there's no space-time path. So, again, what is that? The space-time path. It's just silly.
In part 1 of this series, we saw a car moving with steady motion in a straight line. Let's take a look at its space-time diagram. As it moves through space, it also moves forward in time, represented by this slanted space-time path. That path is invariant, so it's measured the same by everyone. But separately, space and time...
Yes, the speed of light is measured the same by everyone. The speed of light is the same. It always is the same. It never changes. So what? It doesn't mean that any time thing happened here. And again, Einstein's theory is pretty much explicitly saying velocity is causing any distortion in how clocks work. You know, you could pretend he's saying something else, but he's not saying anything else.
Time are relative. From the clone's perspective, he's sitting still in space and only moving through time. On the space-time diagram, you can't change the path. It's invariant, so you have to change the frame itself. The clone's time axis lines up with his path, therefore no moving through space. The accelerating clone from this...
So, no moving through space, you know. So this, you know, somebody argues that this is somehow a great explanation, and I would argue that if I showed that to 100 high school graduates, they wouldn't be able to tell me what those lines represent and what the hell he's talking about.
Video has to be treated the same way. His space-time path looks like this, but he also thinks he's stationary. So his time axis looks like this. It's not straight, it's curved. Unfortunately, we can't see the curvature. We always see the frame as straight, even when it isn't. This makes things look...
Yeah, and the fact is it has to be, in the end, straight. And again, it's just made by without straight lines, you just end up with paradoxes. So again, there are straight lines. And you're just pretending that there's some kind of, some sort of real change in the universe somewhere when there isn't. Photons always move the speed of light, and everything has a motion in a real direction in absolute space. It goes from coordinate here to coordinate there. Now, maybe it has things in it that are moving this way, and things in it moving that way, and things in it moving that way, and lots of ways, but it has a net motion through space at any one moment in time. And the fact is that we're constantly being interacted with. The window's open. I'm getting hit by more photons from that direction. I'm subtly being changed. Okay, and the fact is we're constantly moving through a changing field of energy that constantly is changing where we're going to end up. Because we're not traveling a straight line ever in a net sense. The little bits are all going in straight lines, but we, the collective thing, is constantly changing where we're going. I have rowers in my boat, so to speak, and the rowers are going in all kinds of directions. And when the window's open, then there's a few more rowers that jump in going that way. But there's such a tiny number that you can't see the effect on the boat. There's 1 million rowers and you change 3, right? It's not going to make enough of a difference. Somebody waving their hand in the water outside the Queen Mary isn't going to be able to move the Queen Mary off her course, But if I get hit by enough force, if there's enough of a change, well, then I do change my direction, and then I end up orbiting the sun.
Look a little weird. And the equivalence principle said accelerations were the same thing as gravity. So gravity isn't a force at all.
So again, so just go by the statement. They're saying acceleration and gravity are the same thing when they're different ways of making you accelerate. gravity's one way, this force that moves your atoms, a nuclear force, proven nuclear force, and then there's other forces where something pushes you and crushes your face and makes you move in a direction. Very different applications of force.
Gravity is just an illusion created by our perspective. It's the result of a curved or warped frame. You think this squirrel is falling toward the Earth speeding up at 22 miles per hour per second? Nope.
Yes, because guess what? The center of the Earth's gravity is one of those absolute points. It's an absolute point in space. It just is. And towards that absolute point, everything else, okay, you can play this relativity game, but the fact is you're going to move past real matter that's also in absolute space doing something. So, well, I don't know. There's no perfect way to say this. Their theory, they're playing this game pretending that somehow the Earth in all directions is somehow moving. And we know that's not happening. The Earth doesn't get bigger. So you know it can't be that the Earth is expanding. That's not the explanation. The squirrel isn't getting closer to the ground because the Earth is expanding. You know that much. And you also know that the path of the Earth around the sun is fixed, and that the path in the universe is fixed. It's a fixed path. And it can't be, so you can't argue that for this long amount of time that it takes the squirrel to fall, that for that entire period, somehow the universe changed all the rules and it moved the Earth towards the squirrel. You know that can't be right. So why would you argue that that has any hope of being the right answer? The truth is the squirrel is doing the change. The change happened to the squirrel. It's either moving faster in the direction of the Earth, or it lost velocity that it shared with the rest of the solar system. Somehow it's doing something, it's breaking the solar system's rules and decided it's no longer moving with the solar system, or it's no longer moving with the galaxy, or it's no longer moving with all these other fixed motions. You have to change all of those fixed motions to play this game that the Earth did the changing.
It's moving at a steady speed in a straight line through curved space-time. You think the ISS is orbiting around the Earth in a circle? Nope. Steady speed, straight line, curved space-time.
No, just straight lines that are constantly changing. Straight lines constantly changing. It's not going around in a circle. It's going around in a bunch of deflections. They're just too small for you to see. But that's what really happened. Little atoms inside of the little rowers inside of that Queen Mary keep getting exchanged, and that's what makes the Queen Mary change its direction, is the fact that you change the rowers.
Hopefully this cleared up some things for many of you, and maybe made your brain hurt a little bit. It's good for you every now and then.
Yeah, it's good for us to be arrogantly told what the truth is by preachers who have just a book of babble. A book of wooey nonsense that's completely and obviously inconsistent. Space-time moves planets, quantum events and whatever, wooey forces, virtual photons move atoms. I mean, it's just on its face bullshit.
If you have any questions, please ask in the comments. I have a feeling you're definitely going to need a comment response video for this. Thanks for liking, sharing, and subscribing, and until next time.
Well, I didn't do any of that. So, I did subscribe just because you're a menace, and, got to keep an eye on the menaces, so I guess I did do that, but I didn't like it. I didn't like it in reality or as a virtual click. So, anyway, enough of a video. Hopefully it is a video. Yeah. And say, didn't open the menu. You have saved the current recording yet? Yes, save it. You will be lost. Are you sure you want to quit? No, I don't want to quit. I want to save the damn recording, you retard.